Good. So welcome back to your favorite inorganic tutor YouTube channel. Today, basically, we'll be looking at how to find the inverse of a 3 by 3 matrix, right? Using the adjoint. So let's begin. Now, let's say we have this matrix A, giving us 7, next 6, 3, 4, next 5, next 4, 2, 1, and 8. And we have to find the inverse of this matrix A using the adjoint, right? So first, what we have to find is the determinant of this matrix, right? So finding the determinant of a 3 by 3 matrix, we follow the 3 by 3 operations. The 3 by 3 operations, right? So this is the 3 by 3 operations. Plus, minus, plus. For the first row, plus, minus, plus. Second row, minus, plus, minus. And the third row is plus, minus, plus, right? So that is the operations for the 3 by 3 matrix, all right? So now, we are taking the first row, all right? So taking the first row, we have determinant of matrix A, which is always denoted or usually denoted as A absolute or absolute of the matrix, right? So this in this case is matrix A. So we have this equals, we pick the first element on the first row, which is 7, right? So when you pick that particular element, then you cover that element, cover whatever is under it, and then you cover the element on that row. So we have this element left. So this will be minus 1, minus 5, 1, minus 4, and 8. Minus the second element, right, which is minus 6. But on a 3 by 3 operations, the second element is already negated. So minus minus is going to be plus 6, right? And then we cover all the elements under this 6, right? And then we cover all this. So we have this element and this element. So we have 4, 2, minus 4, and 8. Plus the last element, which is the 3, right? So the last element 3, we cover whatever is under it, and then we cover the whole of the row, right? So we have this element left, which is 4, 2, minus 5, and 1, right? So now this is the 2 by 2 matrix obtained, right? So now we are coming to perform the operations on this matrix and then find the determinant of it. Good. So now 7 into minus 5 times 8, the first diagonal, right? So minus 5 times 8, which is minus 40, minus 4 times 1. But already we have negative. When you are multiplying this diagonal, we use negative, right? So minus minus, and that will be positive, right? So we have minus 4 times minus 1, and that will be positive, right? So plus 6 into 4 times 8, which is 32, minus into 2 times minus 4, plus 3 into 4 plus 10, right? So this, we say that the determinant of matrix A is equal to 7 into minus 36 minus 40 plus 4, right? Minus 30, 40 plus 4. That would be minus 36 plus 6 into 32 plus 8, right? And that will be 40 plus 3 into 14, right? So we say that the determinant of matrix A is equal to minus 252, 7 times 36. But then we have a negative on the 36, so we have minus 252 plus 6 times 40, and that's 240 plus 42, that's 3 times 14. So when you sum up these numbers very well, we have the determinant of A, the determinant of A, the determinant of A as 30, right? So now we have the determinant of A as 30. So what is next for us to do so that we can find the inverse of this 3 by 3 matrix? All right. So next, we have to form or to find the cofactors of this 3 by 3 matrix. All right. 3 by 3 matrix. Now, cofactors of matrix A. You have to get the cofactors of this matrix A. All right. And how do you get the cofactors? We have to use the operations of the 3 by 3 matrix. All right. And the operations of the 3 by 3 matrix are 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to make sure that we have 9 different elements formed from this 3 by 3 matrix. All right. So from here, we come to the first row. Right? Since we are picking the first row of the operations, we take the first row of the matrix as well. So when you take the first row, the first element on the first row, which is 7, when you cover it, you cover whatever is on that row as well, and then you cover whatever is under the 7 as well. Then we have this element left, right? So our first matrix form, or our first 2 by 2 matrix form, is minus 5, 1, minus 4, and 8. Right? And then we cover this, the second element on the first row as well. So when we cover this element, it means we will avoid these ones and we will avoid this as well. So we have this element and we have this element. So we have 4, 2, and then minus 4 and 8. And then our last element that we will be forming on the first row is by covering the last element on the first row, which is the 3. And then when we cover the last element on the first row, we will avoid all the elements under it, and then we avoid all the elements on that row, right? So we have this element left, and that is 4, 2, minus 5, and 1. Right? Now, let's come to the second element, the second row, right? The second element on the second row. So now when we cover the first element on the second row, which is the 4, it means we are going to cover all the elements here, cover what is under it, right? And then we have this element, this element, this element, and that element, right? So we have our first minus 6 and 1, 3 and 8, right? And then we cover the second element on the second row. Then we avoid the element below and above it, right? And then we avoid all the elements on that row as well. So when we do that, then we have this element, and that element, and this element as well. So we have 7, 2, 3, and 8. Then we come to the last element on the second row. So when we come to the last element on the second row, that is minus 4. And you take the minus 4, you avoid the element below it and the element above it. And you avoid all the elements on that row as well, right? So when we do that, we are going to have 7, 2, minus 6, and 1, right? So right now, we are done with the second row as well. Let's come to the last row. When we cover the first element on the last row, which is the 2, right? Then we avoid the element above it. We avoid the element on that row as well. So we have this element left, which is minus 6, minus 5, 3, and minus 4. Right? Now, we come to the second element on the last row, right, which is 1. So we take this 1, we avoid all the elements above it, and we avoid all the elements on that row. So when we do that, we have 7, 4, 3, 4, right? 7, 4, 7, 4, 3, 4, right? And then we take the last element on the last row, right? So when we do that, we avoid all the elements on that row, and we avoid all the elements above it. And then we have 7, 4, minus 6, and minus 5, right? So the last element will be 7, 4, minus 6, and minus 5. So this is the cofactor obtained from this 3 by 3 matrix, right? This is the cofactor obtained from this 3 by 3 matrix, all right? So first, what do you have to do? Now we don't have any signs attached to it, right? Now, on the first row, the first element is supposed to be what? Positive. So we have plus. And the second element is supposed to be what? Negative, right? And the third element is also what? Positive. So we have plus here, right? And the first element on the second row is supposed to be what? Negative, right? And the second element on the second row is supposed to be what? Positive. The last element will be negative as well, in that order. So it goes plus, minus, plus, minus, plus, minus, plus, minus, plus again. So we have plus, minus, plus. All right. So this is basically the cofactor obtained from this 3 by 3 matrix A, right? So let's find the determinant of this, find the determinant of this, and that of this, 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 and that of this, right? And then we can have a square matrix. We can have a simple matrix, right? So now, let's do that. Now, 8 times minus 5, and that is minus 40, right? 8 times minus 5, and that is minus 40, right? Times 8 times minus 5, and that is minus 40, plus 4, because this is going to be 1 times minus 4, which is minus 4. But already this side, when you multiply it, we have negative affecting it, so it's going to be positive, right? So we have minus 40 plus 4, right? And then the next aspect, this 4 times 8, right? And that is 32, right? And then 32 plus 8, right? 32 plus 8. But then we have negative affecting it. We have negative affecting it, right? And then the last end of the first row is going to be 4. This times this is 4 plus 10. It's already positive, so that one is left like that. And then when we come to the second row, this times this, right? 6 times 8. 6 times 8 is also minus, probably it will be 48, but we have negative affecting the 6, so we have minus 48. So we have minus 48 minus 3, because this is going to be 1 times 3, but then this column, this row, or this diagonal, when you are multiplying, it is affected by a negative number, and these two numbers are already positive, so the negative will be affecting it, right? So we have minus 48 minus 3, right? But the sign over here is minus, so we have minus into that. Then this 7 times 8, 7 times 8, and that is 56. So write 56 minus 6. 56 minus 6, because 2 times 3. But then this diagonal, when you multiply it, it is affected by a negative, right? So we have this times this 56 minus 6, and that is what we have here. But the sign over here is already positive, so we don't have any problem with that. Good. So this times this as well will give us 7, right? Because 1 times 7 is 7. Then this times this will give us plus 12, because you know this diagonal is affected by a negative, and then we have a negative there, so negative is going to be positive, so we have plus 12, right? But then this aspect or this element, they are affected by a negative, right? So we have a negative affecting the whole thing, right? So now we are done with the second row as well. Let's move on to the third row, right? So 4 times 6 is 24, but they are all carrying negative, so it's going to be positive 24. 24, right? And then 5 times 3 is 15, but then the 5 is carrying a negative sign, so negative times that negative already there on that diagonal is going to be positive, so we have plus 15, right? Then you know this element is already positive, so that doesn't affect it anymore. Good. So minus into 7, 4, right? 7 times 4, which is 28, right? But then the negative is affecting the minus 4. We have negative affecting the minus 4, so we are going to have minus 28 minus 12, because 4 times 3 is 12, but then this diagonal, when you are multiplying, it is affected by a negative. Good. So here we have 7 times minus 5, which is 7, 5, 35, but then there is a negative attached to the 5, so we are going to have minus 35, right? And then 4 times 6, which is 24, but then there is a negative attached to the 6, so we are going to have minus 24. And we already know that there is a negative affecting that diagonal when we multiply, right? So we are going to have negative 24 times negative is going to be positive 24. Good. So now, this is what we have been able to obtain. So now let's simplify the items in the right? So when we simplify this, this is going to give us minus 36, right? And this will give us 40, but it is affected by a negative, so it's going to be minus 40, right? And then this is also going to be 14, right? So we have 14 on this aspect. Good. Now the second row, minus 48 minus 3, that is also minus 51. So minus 51 is already affected by a negative, so it's going to be positive 51, right? Negative affecting a minus 51, so it's going to be positive 51, and that's what we have here. And then the second element on the second row is 56 minus 6, and that is also 50. The next item on the last item on the second row is 7 plus 12, which is 21, right? And 21, it is affected by a negative, so it's going to be minus 21. 7 plus 12 is 19, but then it is affected by a negative, so it's going to be minus 19. And then 24 plus 15. 24 plus 15, that is also 39. And then the second element on the last row, is going to be minus 40, but then there is a negative affecting it, so it's going to be 40 over here as well. And then the last element on the third row, which is minus 35 plus 24, that is also minus 11, right? Minus 11. Now, we are done with this computation, right? So this is the cofactor obtained. So now, what are you going to do with this element obtained so that we can get our adjoint, right? So now, this should be converted to a transpose. So now let's convert this matrix to a transpose. Convert this matrix A to this matrix A to transpose, or let's transpose this matrix A, right? Let's transpose or let's convert this matrix A to a transpose of A, right? And that is denoted as A power T, right? So we have, and the transpose, what you have to note is that we just turn the row to column, row to column, row to column. That is all about transpose. So for instance, this matrix A, when we transpose it, we are going to have this row will now be column. So we have minus 36, minus 40, 14 as our first column, right? This row, the whole of this row has turned to our first column now. Good. Our second row is also going to be our second column. So we have 51, 50, minus 19, and then our last row is going to be our third row, right? So we have 39, 40, and minus 11, right? So this is the transpose of matrix A. This is the transpose of this covector matrix A, right? So now we have the transpose. What can we do? So that we can find the inverse. Now, our transpose is equal to the adjoint. Our transpose obtained is equal to the adjoint. So, transpose of matrix A is equal to the adjoint, right? So now we know that our adjoint of A is equal to minus 36, minus 40, 14, 51, 50, and minus 19. Then 39, 40, and minus 11. Good. So this is our adjoint of matrix A, right? Right from the cofactor, we find the transpose of the cofactor, right? So the transpose now becomes our adjoint. Good. And the inverse formula, the inverse of A using the adjoint is equal to 1 over the determinant of A times the adjoint, right? So now we have the inverse of A to be 1. The determinant was obtained as 30, so we have 1 over 30 times the adjoint of A, which is minus 36, minus 40, 14, 51, 50, and minus 19. 39, 40, and minus 11. Good. So now, this is going to be the inverse of matrix A, right? So, as we have this, we can now split the 1 over 30 to all the items in the matrix, right? So we have A inverse equals minus 36 over 30. 1 over 30 times minus 36 is minus 36 over 30, right? And then 51 over 30, 51 over 30, 39 over 30. The second element, minus 40 over 30, 50 over 30, 40 over 30. So, left with our last row to multiply. So, that will be 14 over 30 minus 19 over 30 and minus 11 over 30. Right? So now we have this. Let's simplify the items in the matrix. Right? So we have A inverse, or the inverse of matrix A, as minus 6 over 5, and then minus 6 over 5. This will also give us 17 over 10, and then we have 13 over 10 for this row, and then we come to this row, we have minus 4 over 3. This will give us 5 over 3, 4 over 3, and then we have 7 over 15, and then minus 19 over 30. Then the last one will also be minus 11 over 30. Right. So this is the inverse of matrix A obtained. Right. This is the inverse of matrix A obtained. So this is the inverse of the matrix. I hope you observe the process, right? If you are given a 3 by 3 matrix and you have to find the inverse of it using the adjoint, first you find the determinant of that particular matrix, right? Then you form a cofactor of that matrix, say matrix A, right? So after that, of which you use the operations of the 3 by 3 matrix. You use the operations of the 3 by 3 matrix, and then you use it to distribute to all the 9 elements in that matrix, right? When you finish, then you simplify each of the matrix, right? Then you get a single, or you get a 3 by 3 matrix, after which you transpose that particular matrix to get your adjoint, right? And you know that to find the inverse is 1 over the determinant times the adjoint. Thank you very much for watching this video. I really appreciate your time. Don't forget to subscribe, press on the notification bell below, and then I'll keep you updated very soon.